Sean, and this is section 2.1, units and measurements. Units, the tools we use to find the mass or volume of something. It's the label given to the specific measurement. System, international, unites. The measurements that have been used for centuries that aren't exact. You may measure distance by using steps or time by a sundial. Some of these estimates would work for ordinary tasks, but since scientists need to be able to record data correctly for other scientists to recreate later, they need something that can be used over and over again, and to get the same results. They need a standard unit of measurements. In 1960, an international committee of scientists met to update the existing metric system. They revised the international unit system, is called the System International Unites, which is abbreviated SI. Base units and SI prefixes. There are 7 base units in SI. A base unit is defined as a unit of system measurements that is based on an object or event in the physical world. The base unit is independent of other units. The quantities the 7 units measure are expressed in base units or time, length, mass, and temperature. To describe the measurements better, the scientists added prefixes to the base units. Time. The SI unit for time is in seconds. The physical standard used to define the second is the frequency of the radiation given off by a cesium-133 atom. These cesium-based clocks are used when highly accurate timekeeping is needed. Length. The SI unit for length is in meters. A meter is the distance that light travels in a vacuum in a second. A vacuum exists where no space contains matter. The meter is close in length to the yard and is useful when measuring the length and width of a small area. Mass. The SI unit for mass is in kilograms. A kilogram is equal to 2.2 pounds. Temperature. People often use qualitative descriptions like hot or cold. Temperature is a quantitative measurement of the average kinetic energy of the particles that make up an object. As these particles are in motion, an object increases, so does the temperature of the object. To measure temperature, you use a thermostat or a thermometer. The thermometer is a long, narrow tube with a liquid in it. The height of the liquid indicates the temperature outside or inside. Fahrenheit, used in the United States mostly. Celsius is used in most of the world. And the Kelvin system is the SI. The reason it's easier to flip backpack filled with gym clothes than it is with books is because of density.
Hi, my name is Natal Thompson, and this is Chapter 2, Section 2, Scientific Notation and Dimensional Analysis. Scientific notation can be used to express any number as a number between 1 and 10, known as the coefficient, multiplied by 10 raised to a power known as an exponent. Addition and subtraction. In order to add or subtract numbers written in scientific notation, the exponents must be the same. Multiplication and division. Multiplying and dividing numbers in scientific notation is a 2-step process, but it does not require the exponents to be the same. Dimensional analysis. A systematic approach to problem solving that uses conversion factors to move or convert from one unit to another. And lastly, conversion factor, a ratio of equivalent values having different units. For example, dimensional analysis can be used to calculate the number of pizzas that must be ordered for a party. How many pizzas we need if 32 people eat 3 slices. If 32 people eat 3 slices per person, and there are 8 slices in each pizza, that'd be 12 pizzas.
Hi, I'm Mo Murai. This is Chapter 2, Section 3, Uncertainty in Data. Accuracy and precision. Just as each teaspoon you measure in the kitchen contains some amount of error, so does every scientific measurement made in a laboratory. When scientists make measurements, they evaluate both the accuracy and the precision of the measurements. Although you might think that the terms accuracy and precision basically mean the same thing, to a scientist, they have very different meanings. Accuracy and precision are very different even though they sound like the same thing. Accuracy refers to how close the measurement is to the accepted value, while precision refers to how close each measurement is to one another. Error and percent error. The known density of sucrose is an accepted value, which is the value that is considered true. To evaluate the accuracy of the experimental data, you can compare how close the experimental value is to the accepted value. Error is the difference between the experimental value and the accepted value. Error equation, error experimental value minus accepted value. Percent value is the error as a percent of the accepted value. Percent error equation. Percent equals error divided by accepted value times 100. Significant figures. Often precision is limited to the tools available. For example, a digital clock that displays the time at 12:47 or 12:48 can record time only to the nearest minute. With a stopwatch, however, you might be able to record to the nearest hundredth second. As scientists have developed better measuring devices, they have been able to make more precise measurements, of course, for measurements to be both accurate and precise. The measurement device must be in good working order. Additionally, accuracy and precision measurements rely on the skill of the person using the instrument. The user must be trained and use proper techniques. Remember that measurements reported with a lot of significant figures must be precise but not accurate. For example, some chemistry labs have balances that report mass to the nearest hundredth of a gram. If you and each of your classmates measure the same copper cylinder on the same scale, you would probably have a group of very precise measurements. But what if the scale has been previously damaged by an object that was too large for it? Your precise measurements would not be very accurate. Rounding numbers. Calculators perform flawless arithmetics, but they are not aware of the numbers of significant figures that should be reported in the answer. For example, a density calculator should not have more significant figures than the original data with fewer significant figures. To report a value correctly, you often need to round. Consider an object with a mass of 22.44 grams and a volume of 14.2 centimeters cubed. When you calculate the object's density using a calculator, the display answer is 1.580281 grams centimeter cubed. Addition and subtraction. When you add or subtract the measurements, the answer must have the same number of digits to the right of the decimal as the original value, having the fewer numbers of digits to the right of the decimal. For example, the measurements 1.24 milliliters, 12.4 milliliters, and 124 milliliters have 2, 1, and 0 digits to the right of the decimal, respectively. When adding or subtracting, arrange the values so the decimal point align. Identify the value with the fewest places after the decimal point and round the answer to the number of places. Multiplication and division. When you multiply or divide numbers, your answer must have the same number of significant figures as the measurement with the fewest significant figures.
Hi, my name is Brian Gutierrez. My section is 2.4, Graphing. Using data to form a graph can show patterns that are involved. A graph is a visual display of data. Graphing is just one of many ways for scientists to analyze data. Circle graphs. Circle graphs are everywhere. For example, newspapers and magazines. Another name for a circle chart is a pie chart. Bar graphs. Bar graphs are used to show many varieties of different topics / categories. Bar graphs can be used to show population from different countries. Line graphs. Line graphs are really popular in chemistry. Line graphs are used for representing the intersection of two variables. Different types of variables are independent variables. Independent variables are plotted on the x-axis. Dependent variables are plotted on the y-axis. Slope equation. Slope equation is slope equals rise over run. To calculate the slope of the line, substitute the x and the y values for points A and B in the slope equation. Then solve. Interpreting graphs. You must first find the independent and dependent variable. Then you must find out if the variable is linear or nonlinear. Once you are completed with those steps, find out if your slope is positive or negative, if your relationship is alinear. Interpolation and extrapolation. Always know when points on a line graph are connected, it must be continuous. Interpolation is the process where continuous data allows you to read the valve from any point that falls between the recorded data. When you extend a line beyond the plotted points in order to estimate valves for the variables, it is called extrapolation. Extrapolation is very difficult. It can lead to many errors. Interpreting ozone data. Having data from two time periods on the same graph allows scientists to compare recent data with data from a time before the ozone hole existed. Vocab for Chapter 2. Base unit. A defined unit in a system of measurements that is based on an object or event in the physical world and is independent of other units. Density. The amount of mass per unit volume, a physical property. Derived unit. A unit defined by a combination of base units. Kelvin. The S1 base unit of temperature. Kilogram. The S1 base unit for mass. Liter. The metric unit for volume equal to 1 cubic decimeter. Meter. The S1 base unit for length. Second. The S1 base unit for time. Conversion. Fact. A ratio of equivalent values used to express the same quantity in different units is always equal to 1 and change the units of a quantity without changing its value. Dimensional analysis. A systematic approach to problem solving that uses conversions, factors to move from one unit to another. Scientific notation expresses any number as a number between 1 and 10, known as a coefficient, multiplied by 10 raised to a power known as an exponent. Accuracy refers to how close measured value is to an accepted value. Error. The difference between an experimental value and an accepted value. Percent error. The ratio of an error to an accepted value. Precision. Refers to how close a series of measurements are to another. Precise measurements. Show little variation over a series of trials, but might not be accurate. Significant figures. The number of all known digits reported in measurements plus one estimated digit. Graph. A visual display of data.